We'll start joining and fastening today. The purpose of the joint to keep the component part or assemblies to or structures together. Development of welding relatively recent. Versatility provides many applications. Open replaces bolting and riveting. So we have so many welding process. Arc welding, AW, soldering is high energy beam welding, HEBW, resistance welding, RW, solid state welding, SSW, oxy-fuel gas welding, brazing, other welding and joining. So there are so many, you can go through it. Master chart for welding and joining process, American Welding Society. Atomic bonding is essential, atomic cleanliness and closeness is essential. Melting, common but not essential. Fusion bonding. Liquid metal. The most important welding process, particularly those in which height strength are a principal goal, make use of fusion bond, in which surfaces of the pieces to be joined, parent or base metal, are completely melted. As shown in 8.3, liquid metal then close together to form the union, and cleanliness is established as the impurities float to the surface. No pressure is necessary, and the parts to be joined need only to be located and held in proper relationship with each other. Metallurgical effects is like casting. Fillers sometimes added. Welded joint strength. The strength of the fusion welded joints depend on the composition and metallurgical structure of the filler metal and base metal. And in structural changes that takes place in the heated areas of the base metal adjacent to the weld on the perfection with which the desired geometry of the weld is established, or residual stresses build up as a result of the differential heating and cooling, and on presence of absence of impurities on the weld. Pressure bonding. Heat adds cleanliness and closeness. The term pressure bonding or pressure welding is sometimes misleading in that some heating is involved in the process. Pressure alone may be sufficient to form the bond, but heat is used for two principal reasons. The close union required is established by plastic flow, as indicated in figure 8.4, and in general metals become more plastic and strengths are lower when the temperature is raised. Pressure and flow cause some fragmentation of the oxides on the surface because it is quite brittle and cannot maintain a continuous film as the metal flows plastically. Pressure bond. Overall joint efficiency is high, while a small amount of fusion of the base metal may occur in the same pressure bonds. It is incidental. No pronounced solidification shrinkage occurs as it does in fusion welds. Consequently, distortion of the welding is usually very slight. The efficiency of pressure bonds based on the original area may be high as 95%. Flow bonding, base material not melted. Joint defined by temperature and spacing, three different operations using flow bond named as brazed welding, brazing, and soldering. In brazed welding, the filler metal is a metal or alloy having the melting point above 425 degrees centigrade and composition significantly different from the base metal. So it is used for that. In practice, the component alloy uses such filler are copper and silver based. Occasionally, pure copper is used for brazed welding steel. Soldering and brazing. So this process requirement between mating surfaces filler material when the heated slightly above the melting temperature is drawn into the microscopic voids. So in both this capillary action, this liquid metal is going to inside this microscopic void. Both brazed welding and the brazing occurs at temperature 449 degrees centigrade. Soldering operation, formation of the solder have been introduced. This and this, dripping the components to the solder pot to cover the lids of solder and placing them on the solder patches deposited on the printed wire boards. The slits and patches are cleaned using fixed fluxes. The connections are then heated to flow the solder and form the joint. Not going to too much to this. Your question regarding this is brazing is done at temperature 449 degree and brazing uses several varieties of filler metal which is chosen based on its application. The brazing when used alone designated the use of filler metal similar to the use of brazed welding. So both are above 449 degrees centigrade, below is soldering. Joint thickness is critical to strength. It depends on the width. Diffusion bonding, another method of joining similar and dissimilar materials. Diffusion bonding literally diffuses the mating surface with the application of immense pressure and heat. Pressure, temperature, time independent variables. Present use is limited. The process has been used most of joining special alloys in aerospace and atomic energy application. Adhesive bonding. Adhesive bonding with few exceptions. A quick and affordable method for joining both similar and dissimilar metals along with other materials in terms of strength, structural adhesive when applied correctly are on par with some cast iron. It is not with the welding as par, but with cast iron. So designing the joint, welding, unitized product assembly, fastening, design the welded joints weld type usually distinguished from the joint type. So fillet, square groove, bevel, V groove, J groove or U groove. Configuration determines joint type. Design consideration. Butt joint. The joint are these types. Arrow of welding symbol, arrow side joint, and other side joint. T joint, arrow of welding symbol, same arrow side joint or other side joint. Lap joint, arrow of the welding symbol, so other side of member joint and arrow side member joint. Corner joint, arrow side of the joint, arrow of the welding symbol, and the other side. Other side is this, and the other arrow side is the one. Then edge joint. These are 5 types of joint. This is the arrow of the welding symbol, arrow side joint. There is no other side for this 0 to 30 degree. In between, it is called corner joint. These are edge joint. Unit structure. Special consideration. Weldability. Weldability varies with material. The relative ease with which a sound union may be produced between two parts by welding is known as weldability of a metal. Hardenability, especially important for steels, is consideration of the hardenability of the metal. Thermal conductivity, another factor affecting weldability is the thermal conductivity of the metal. If a metal is infinitely high thermal conductivity, it cannot be fusion welded at all because it cannot be locally melted. Composition is important. Recrystallization, heat produces other effects or structures than those of quench hardening steels. Materials that have been cold worked is automatically recrystallized during welding, usually for a considerable distance away from the actual weld. This creates heat affected zone. Corrosion resistance, some distortion is there. So corrosion resistance may vary for stainless steel and all. Preheat and post it. Why you do preheat? Preheat is done because when you are welding something of high thickness, it is going for quenching. But now When you preheat, it acts as a big heat is there itself, so it cannot quench. For post heat, to remove the residual stress, then if you maintain at that temperature some recrystallization, you remove the stress and all. Welding symbols, weld testing symbols. Okay. Elements of a welding symbol, American Welding Society, as per this. So there is the upside of the arrow and bottom side of the arrow. So how and what is the difference? We'll go from the side arrow connection reference line to arrow side members of the joint of arrow side of the joint. Weld all around symbol, field weld symbol, there is a flag, pitch center to center spacing and weld segments. Length of the weld segment, this is used for fillet, root opening, depth of filling and plug and slot welds. Groove angle, included angle or countersink of plug welds. Finishing symbols, counter symbols. Counter is rough or plain or grinded, polished. Groove weld size, depth of the weld size, strength of the certain welds. Specification process or other reference may be omitted when reference is not used. So weld symbol, the number of spots, seam, stud, plug, slot or projection welds. Reference line. So when reference line, this symbol, this side is other side. Anything written here is other side, anything written bottom side is arrow side. Elements in this area remain as shown when tail of the arrow are reversed. Weld symbols shall be contained within the length of the reference line. So anything on the top is other side, bottom is the arrow side. So this you have to remember. Examples, welding symbol and use. Maybe one symbol will come. Just basic welding symbols. So that is what other side, arrow side, test all around. MTRT, testing symbol, general form combined with welding symbol. Portability an important advantage, other gases less used. Arc welding process, consumable electrodes, gas metal arc welding, GMAW, formerly referred as metal arc inert gas, MIG welding, flux core welding and shielded metal arc welding, SMAW, or stick welding are all examples of welding process where the welding electrodes are consumed. Stick welding and flux core welding processes leave protective cover of slag over the weld, preventing oxidation from the occurring, while the molten pool solidifies underneath. GMAW and flux core welding process utilize gun, which fits the wire electrode into the weld. GMAW welding typically uses an inert gas, usually argon and helium, to locally provide a protective environment around the molten weld pool to prevent oxygen from occurring and contaminating the weld. The electric arc ionization establishes current path. So ionization is from the flux gas. So the electric arc is one of the hottest source of energy available except for nuclear reaction. Arc column temperature are near 6090 degrees centigrade, which is well above the melting point of common metals and alloys. So with typically arc welding condition 25 volt 300 ampere, the total energy supplied would be 6550 kilocalories per hour. The core of the electrode gives this ionization and the gas. The arc frequently serves as one electrode, some metal lost during the transfer. Gas shielding improves quality. The welding arc, the molten globule, gaseous shield, arc column, molten pole. There is two polarities, straight polarity, welding rod negative. The negative is there, you have electrons, so it gives you high heat, exert a measurable influence on the burn-up rate and the amount of sputtering. When the rod is negative, setup is called straight polarity. The rod is positive, the setup is called reverse polarity. So it is having slight less heat. Effect manufacturers designate these preferred polarities for the most rods. No sputter, nothing. So arc welding versatile and important. Percussive welding. One other use of the electric arc is percussive welding, a process more closely associated with pressure than fusion method, and used only for making butt joints between the flat ends of workpiece without filler metal. Then stud welding. Then go through it because book is there. Welding equipments and procedures. Arc welding electrodes, coating provide protective atmosphere or sometimes alloys. Slag protects hot metal. Coating may add filler. Modification of arc welding for special purpose manual procedures are very versatile. Manual welding economical for small quantities. If high quantities, it is not economical. Quality and speed improves with modification. Wire electrode may supply filler. Automatic or manual. Several gases used as shields, argon, helium, mixture of argon and helium. The arc welding process non-consumable electron. So gas tungsten arc welding GTM and GTAW makes use of torch which has a non-consumable tungsten electrode, and you are applying another filler wire for welding. Schematic of gas metal arc welding GMAW, and this is for GTAW. There is a tungsten electrode, arc and gas shield. You can apply filler, and there is shielding gas, inert gas. Same here, MIG or MAG. So is shielding gas coming wire drive. The wire is fed continuously. This is the pillar wire. Automatic welding under flux. A high production process in wide use is submerged arc welding SAW. There is work and the granular flux upper. So flux is going on adding, and then wire drive is directly beneath the flux. Once it started the arc, it is continuously going on welding, and we can recover this unused flux. Some flux it will use for welding, and some recovered flux can be reused as per your WPS and all. So maybe somebody don't want to use recover flux. It is up to their WPS. High energy beam welding. With high energy beam welding, a flow of electrons from an electron source gun or photons from a laser beam is focused to power density is large enough to melt and vaporize the metal being joined. Several processes such as selective lasers, sintering, SLS, weld thin layers of powder from the material. The process also opens the field of micro joining when the weld dimension and are less than the millimeter, where the spot size, beam control, and part manipulation become more challenging. Electron beam welding is valuable for welding beryllium, molybdenum, zirconium, hafnium, and other refractory materials difficult to weld by other material methods. So EBW. The process uses high cost equipment. Electron beam gun. Energy for heating may be made available in many forms. The electron beam gun. A stream of high energy electron is focused electrically towards the spot on the surface to be heated. Rapid localized heating takes place with possibility of melting or welding or of complete vaporization for removal metal. The process is carried out in vacuum so that no product or products of combustion and no contamination or oxidation of the heated work occur. It needs vacuum for electron beam EBW. Laser welding. Laser beam welding LBW uses high focused laser with spot size typically ranging from 0.2 mm to 13 mm. Plasma arc welding. In the plasma arc process, a stream of gas is ionized by heat as it passes through the electric arc by one of the two methods shown in the figure 8.24. The thermal expansion of gas stream causes it to flow at supersonic speed. This timer is restricted by the magnetic properties of the arc. The drop in the temperature caused by contact with relatively cold work surface result in loss of ionization and the release of large amount of heat directly at the surface to be heated. The process has a high intensity and a high rate of heat transfer, which makes it useful for welding high conductivity metals such as aluminum. Forge welding is plasma arc. So if this like scarf, lap, jump, butt and clef, it is forge welding. A heated and pressure applied pressure. Cold welding. In cold welding, tremendous compressive force diffuses the contacting surface to join the material together. This is the cold welding. Ultrasonic welding. Vibration aids cleaning. Cold burn. So oxide dissipated by fragmentation, deformation, flow, and diffusion. So pieces being joined. Pressure provided by dies to cause metal flow and intimate contact. Friction welding. Apply friction. Electroslag slag welding. The slag protects the heated metal. The principle of electroslag welding is illustrated in figure this. So multiple electrodes needed for heavy section. This is friction welding, mechanical fragmentation of the surface while rotating. One is stationary. Heat developed from friction and then welding. Resistance welding, RW, and sometimes referred to as spot and seam welding. So this is like electroslag welding. Here's the starting plate. This is the work. The resolidified material. Let us see from here. The electrode guide or multiple electrode guide. Electrode wires. This molten slag and molten metal. Run-up tabs. When you have water-cooled rear shoe, front shoe, so both sides they have water-cooled shoes to cool this big size welding pool. Melting incidental only. Dissimilar metals may be joined. Spot welding for joining sheet metal. Modified spot welding. So this is the spot welding. You can parts to be joined. Electrode. The variation of spot welding, projection, and seam welding. So either of the two. These are projection welding. This is seam welding direct. Spot welding is an important assembly process. Explosion welding. Explosion welding is a solid state metal joining process that uses an explosive force to create an electron sharing metallurgical bond between the two metal components. Progressive cleaning and welding. We already see in the previous chapter about this figure and all for this explosion welding. Discontinuities in welds. You all know all this. It's not new to us. Those associated with drawing and the dimension requirement, those associated with structural discontinuities in the weld itself, those associated with properties of weld metal and welded joint. Dimension effect, wrapping, differential heating and cooling setup, unequal stresses in the weld area that must be observed by the position of shift, wrapping, deformation, plastic flow, or cracking in if neither of the other can occur. For example, the angular distortion of a butt joint produced with a single bead preparation is shown in figure 8.32. Although wrapping is inherent in process, can be minimized by proper welding control, including joint preparation where necessary. Fixtures may be used to minimize the distortion. In some cases, spinning to produce localized deformation of post-heating to equalize residual stresses may be needed to prevent cracking. So you can make double V. The joint design is most important, or else you will get this distortion. Weld dimension and profile. So you have problem with this. Usually the unit strength of the weld material is weaker than the unit strength of the base metal. It joins sensitive not only to the chemical composition normally used, but also the possible discontinuities it may contain in the finished weld pillar. When the full strength is desired, welds are made slightly oversized with given shape. If the convexity is too large, though through time and material uh, are wasted and the chance of other discontinuities is increased. Final weldment dimension. All weldments are designed to meet dimensions necessary to function properly or unite with other parts. Welds, especially when multiple, must be carefully controlled. So these are some profiles of fillet welds: undercut, convexity, not ideal, insufficient throat, undercut, overlap. Profiles of double B welds. A is the ideal reinforcement, and this is undercut, overlap. Well, so we stop here.